Hi, this is lecture number 6, and it's going to be a brief lecture that's going to point you towards some materials on the linear quadratic permanent income model. So this is in the tradition of constructing simple linear quadratic examples of models that perhaps we'd actually like to do in more generality, but we use linear quadratic because it's easy to compute. We can get fast results. Often the approximations are quite good, but we have to be aware that the restriction to linear decision rules can sometimes be limiting. And in particular, for what we've been studying in this class, it is limiting in a particular direction because it's going to exclude precautionary savings motives. And I'll say a couple words about that, but I don't want to focus on that. If you look at chapter 17 of RMT, it'll kind of tell you why linear quadratic is going to shut down the force of precautionary savings. I'll say a little bit more of this. But my purpose in this is to draw your attention to an isomorphism, that is a relabeling of variables that was quite famous and quite productive, that was done in exactly the context of this model. So I'm going to be using two resources. Both of these are quant-econ lectures. There's a couple of quant-econ lectures on a permanent income model, and I'm going to be using the second one. Okay, so in the first one, it is several characterizations of the linear quadratic permanent income consumption model are pulled out. The first thing was Robert Hall's striking result is that consumption is a random walk, regardless of the stochastic process for income. And the second is that financial wealth has a unit root, and it's co-integrated with consumption. So this is a leading textbook example of an economic model that leads to co-integration, in which economic optimization, the agent's optimization, produces co-integration as an outcome. So both of those things are interesting conceptually, and they were exploited econometrically by Hall and other people. Okay, so what we're going to do is this isomorphism, that means has the same structure. We're going to show an isomorphism where we can convert Hall's model into a model of Robert Barro, and that's a tax smoothing model. And that, by the way, is that tax smoothing model was it's a formalization of Barro's 1979 paper, and it's a model that that Lucas and Stokey had in mind when they created their model, their 1983 model. And as you'll quickly understand, their 1983 model fails to recover Barro's key result. And his key result is going to be a relabeling of this consumption as a random walk, regardless of the stochastic process of labor income. That's where we're going. So this lecture does a whole bunch of stuff. This lecture actually teaches you how to map this linear quadratic permanent income model into some nice quant-econ classes, where that's a class in an object-oriented programming sense. But that's for another day. So, okay. So I'll let you look at the introduction, And actually, I'm just going to show you one part of this lecture. I'm going to show you the setup, and I'm going to show you the isomorphism. That's all I want to stress. And for the purposes of this second-year macro class that Alessandro and I are presiding over, this isomorphism is all that I need. Okay, so here's the permanent income model. Small c is consumption. There's one consumer. And this consumer wants to maximize the conditional expectation of the discounted sum of utilities. And utilities are going to be, and here's the thing, they're going to be a quadratic function of consumption. Gamma here is going to be bliss consumption. So the spirit of this is we're going to make a utility function that looks like this. And the hope is gamma is way far away. So way far away from where consumption is actually going to be. So consumption is going to oscillate in this region where marginal utilities of consumption are positive. But gamma is bliss consumption. And a key feature is going to be, if you glance at chapter 17, which I posted, key feature is going to be that the marginal utility of consumption is going to be linear. And eventually, at gamma, consumption equals gamma is going to go negative. And the whole spirit of precautionary savings, I'll just tell you, the whole precautionary savings literature, that depends on the marginal utility of consumption not looking like this, but instead looking like this, and marginal utility of consumption being bounded below by 0. And the key thing is that it could actually look like this, but eventually it has to be 0. So eventually, this is a punchline of chapter 17. If the marginal utility of consumption looks like this blue line, either of these blue lines, consumption is, well, some exotic things are going to happen. A certain martingale convergence result is going to be activated. But that is shut down in this lecture. It's shut down in this lecture because we're assuming a marginal utility of consumption that looks like this. Okay, so that's a digression, but you could store that for what the essence of the precautionary savings models are. Okay, so going back, consumer wants to maximize this. That's his utility function. We've rigged this so that the utility function is quadratic, and we're going to rig the constraints so that they're linear. So the consumer is going to have a sequence of budget constraints, just like it says here. YT is going to be his labor income, what Milton Friedman called his non-financial income, his income from human resources. BT is going to be a one-period risk-free bond that he owns at the beginning of period, at the beginning of this period. So that he owes. There's dyslexia again. He owes. So if we just read this, this is the way this goes. This is his labor income. What he does is he borrows in a risk-free bond. He borrows. That's his borrowing plan. He borrows that. He owes BT plus 1 units of goods next period. For that, he gets 1 over 1 plus R, where 1 plus R is a gross risk-free interest rate. And what can he do with these resources? Well, he has to pay off the bonds the debt that he owes, and he can consume. That's it. And we're going to have a no Ponzi scheme condition. And there's technically various ways to do that. We're going to make it's going to suffice for us if we make this B program be square summable, discounted square summable. So this is a boundary condition that will work for us. And then we're going to follow Hall, and we're going to assume that the gross interest rate times the discount factor is equal to 1. And then the final thing is we're going to let the dynamics of YT follow a we're going to let the dynamics of Y follow a linear state space system. So Z is going to be a finite dimensional vector, WT plus 1. Is going to be normal, 0, I. Okay. Okay. Okay, so, well, that's the model. The solution is going to be a consumption program. Finding the state's going to be art. Consumption is going to be a function of that could be determined. It's going to be a linear function of the state variables that help predict income and the debt that you owe. And then there's going to be a law of motion. Call this L1 and call this L2. That's what the dynamic programming yields. And then this is going to turn out to have the feature that consumption's a random walk, and it's going to turn out that borrowings have a unit root, and they're co-interrelated with consumption. Those are the results. And you could look those up in the previous lecture. Okay, what I want to focus on here is this isomorphism. So it turns out that the LQ permanent income model is isomorphic with a version of Barro's 1979 tax smoothing model. So here's the way it goes. And all we're going to do is we're going to match up variables. So in the LQ permanent income model, the household faces an exogenous process of non-financial income. And he wants to smooth consumption across states and time. Why does he want to do it? Well, when we built in this objective function with this quadratic U, he has a preference for smoothness of consumption. So when in Barro's model, what's the deal? The government's going to face an exogenous sequence of government purchases, excluding interest payments. And the government is going to want, again, so the government faces an exogenous sequence of government purchases. So this is going to match this. And the government wants to smooth households' tax collections across states and time. So this is going to match this. So now we're going to use this isomorphism. We're going to let total tax collections in Barro's model equal consumption in the permanent income model. We're going to let exogenous government expenditures equal non-financial income in the permanent income model. We're going to let B, which was is going to be government risk-free one-period debt in the Hall model, in Barro's model. We're going to let that be equal to VT, risk period, one-period debt in the LQ permanent income model. And we're going to let R, the gross interest rate on one-period debt in Hall's model, equal the gross rate of return on financial assets in the permanent income model. So we're just going to match those things up. And then the two models are mathematically equivalent. So all the characterizations of C, Y, and B in the LQ permanent income model are automatically going to apply to a tax, government expenditure, and government debt process in the Barro tax smoothing model. So what do we get from this? Get an easy way to read Barro's paper, because what we're going to find now is, come back here, is tax collections are a random walk, and they are independent of the process for government expenditures. And and financial wealth, well, here government debt has a unit root and it's co-integrated with taxes. We just rewrite this as TT. We write this as government debt, and we write this as total tax collection. Okay, so this, my writing's terrible. Okay, this is basically all we need to take away from Barro's model. It's a widely used and referred to model. And you'll notice the starting point for Lucas and Stokey. Lucas and Stokey get very different results. Tax collections are not a random walk. They typically inherit the characteristics of the government expenditure process. They are smooth, however. And then the AMSS paper is an attempt to put deeper foundations behind the Barro model, because Barro takes, if his utility function has to be in some sense it raises the question, why does the government want to do that? And the AMSS model supplies a version of that. And the AMSS model has incomplete markets, but it goes partway in recovering some of Barro's results. But it also has some Lucas Stokey flavor. So this is why I want you to, this is why I want to tell you about this. This is the main message. Okay, I want to show you one more thing. It's another QuantiCon lecture. This is called Consumption and Tax Smoothing with Incomplete Markets. And what this does is, I'll just give you a short reader's guide to this. What this does is it takes a very simple LQ model and it describes a consumption smoothing setting. And it gives you essentially what it does is it does a baby's version of chapter 8 of RMT 4. And it's a baby's version in the sense that it just is everything with quadratic preferences and linear laws of motion for endowments. That's it. And then what it does is it does both a complete markets version, and then it in a chapter 8 style, and then it does an incomplete markets version. And it uses the isomorphism, so it does both a tax smoothing model and a consumption smoothing model. They're basically the same thing, viewed right. And then it also does this with two kinds of driving processes for the consumer's income, either a Markov chain, discrete state Markov chain, or a linear state space representation. And things are really easy to compute. Again, we use the isomorphism that we've just talked about. I think I just want to tell you about that, and I'll make these available. I think this is going to be enough for for this lecture 6.